Hey, and welcome back. This is Miss Glink, and the purpose of this video is to review how to find equivalent fractions. So remember, the root word of equivalent is equal. So basically, even though they might look way different, I'm going to show you ways to prove that two fractions are equal and how to find missing either a numerator or a denominator. So first of all, I'm going to start with the fraction 1/2. So I know that the relationship between 1 and 2 is that 1 times 2 gives me 2. Or you can look at it as 1 is half of 2. So if I want to know if a fraction is equivalent to 1/2, what I might do, like let's just say we want to compare 1/2 to 4/8. Well, what I know about equivalent is you have to be able to do the same thing to the numerator as you do to the denominator. So I'm going to focus on the two denominators, the 2 and the 8. Well, how do I get from 2 to 8? Well, one way is to add 6, but another way is you can also multiply. So I know if I take 2 times 4, it gives me 8. So if I want to test this out, if I think that 1/2 might be equivalent to 4/8, whatever I do to the bottom, I have to do to the top to make it equal. So let's just see if 1 times 4 is 8. 1 times 4 is 4. Well, it is. So I'm going to circle this 4/4 right here. 4/4. You agree that the numerator is equivalent to the denominator. When you have a numerator and denominator that are the same, they equal 1 whole. So it's kind of like you're taking the 1/2 times 1 whole and giving you 4/8. So if I have a fraction 3/5 and I want to know if it's equivalent to 5/15, my rule is I have to make sure that it's multiplied by not necessarily 4/4, of course, but something that is equivalent to 1 whole. So let's just try the denominators. I know 5 times 3 is 15. So if it works on the top, that means I can take 3 times 3 and give me 5. Oh, definitely not. That doesn't work. I cannot multiply a number by 3 and get to 5. So this fraction, 3/5, is not equivalent to 5/15. But what if we have 3/5 and let's just say, is it equal to 9/15? Well, I know 5 times 3 is 15. Let's see if 3 times 3 is 9. And it is. So we were able to take our 3/5 times 1 whole, because 3/3 is the equivalent to 1 whole, and find an equivalent fraction. But what if you're given a fraction with a missing numerator or a missing denominator? How would you do that? Well, you would do the same way. What you want to do, let's just focus on this top left section. The first thing you need to do is focus on, do I know both my numerators or do I know both my denominators? Well, in this case, I know both of my denominators. So let's see how we get from 3 to 18. Well, knowing my multiples, I know 3 times 6 gives me 18. So I have to do the same thing. It's like a scale. You have to balance it. I also have to multiply the top number, the numerator, by 6, since I did the same thing to the bottom. So that means my missing numerator is 6. So over on the right-hand side, I have 3/8 equals 18 over blank. In this case, I know both of my numerators. Well, knowing what I knew before, 3 times 6 equals 18. So I have to do the same thing to the bottom to find my missing denominator. 8 times 6 is 48. On the bottom left-hand side, I have 4/5 equals 20 over blank. Well, I know both of my numerators, so I can do 4 times 5 and give me 20. So I have to do the same thing to the bottom. 5 times 5 is 25. On the bottom right, I have 7/9 equals blank over 27. So I'm missing one of my numerators. Well, I know both my denominators, so I can use that. So I take 9 times 3 to get me 27, which means I have to do the same thing to the top to find equivalent fractions, since you're using equal numbers to multiply both the numerator and denominator. 7 times 3 is 21. You notice, and this is what I do. So I always double check to make sure. Did I use the similar or the same numerator and the same denominator? Did I multiply my numerator and denominator by the same number? So if I look at the top left, I did multiply both by 6. So I put a big slash like that, and that represents one whole. So it's just my way of marking it, saying yes, it's equivalent because I multiplied by a fraction. They're equivalent because I basically multiplied them by one whole. On the top right, these are also equivalent to one whole. On the bottom left, I multiplied both by 5s, so 5/5 is equivalent to one whole. And on the bottom right, I also multiplied by an equivalent fraction found equivalent fraction because 3/3 is the same as one whole. Of course, you won't always have to find specific missing numbers, so this is just a little bit of how you could find equivalent fractions. So if you have 2/3 and you're not given any number on the top or bottom to make it equivalent to, just pick any number to multiply by. You can multiply it by 100. I mean, as long as you multiply it by the same, 100 over 100 is equivalent to one whole. As long as you're multiplying by the same number for both your numerator and your denominator, you'll get an equivalent fraction. And then same thing goes if you were to have, let's just say 4/6. You could multiply by 10, each of them by 10, and you will get 40 over 60, because 10/10 is equivalent to one whole.